Hello and welcome to Module 10, which deals with shipping and the marine environment. Now, before I start, or right at the start, I want to give you some background information as to why environment is such an important consideration in ship operations management. Now, in recent years, business practices have come under increasing scrutiny by stakeholders who view companies through the lens of corporate social responsibility and sustainability. So, with corporate social responsibility, what we mean is it's basically a term that is used to describe the ways that a business takes into account environmental, economic, and social impacts of decisions and actions it is involved in. So it is a concept where economic growth is also linked to social and environmental well-being. So in the past, many businesses were primarily concerned with increasing the value of their shareholders, or in other words, increasing the value for their owners. But recently, there has been increasing focus on increasing the return, not only for shareholders, but for stakeholders as well. So, stakeholders are the people who are affected by the actions and performance of the business, and they include both internal as well as external parties. With regards to sustainable development, now there is a quite a popular definition which is on the slide here, which came from the World Commission on Environment and Development in 1987. And basically, it says sustainable development is development that meets the needs of the present without compromising the ability of future generations to meet their own needs. So, this definition of sustainable development suggests that meeting the needs of the future depends on how well we balance social, economic, and environmental needs when we make the decisions today. So in this module, we will concentrate on just one aspect of corporate social responsibility and sustainable development, and that is the natural environment in the context of shipping. Now, the environment is an emotive issue, and you can see why. Here you've got the picture of a dead whale, which is covered in oil. So um, people are naturally concerned about shipping activities. Having said that, taken overall, from a global perspective, shipping is a very minor contributor to marine pollutions. Despite that, ships are required to comply with strict conditions for the discharge of pollutants into the marine environment. And we would examine the international instruments that are in force currently in place for regulating pollution from ships. And that leads us to the three focus questions, which are what is the impact of shipping on the marine environment? What are the pollution prevention standards? And how is the pollution from ships controlled? And in case pollution incidents do take place, who pays for costs and damages which result from a pollution incident? So let's start by looking at the definition of marine pollution. Now, this definition is provided by the United Nations Convention on the Law of the Sea, and if I can just read it out, it basically says pollution of the marine environment means the introduction by man, either directly or indirectly, of substances or energy into the marine environment, which results or is likely to result in such harmful effects as harm to living resources and marine life, hazards to human health, hindrance to marine activities, including fishing and legitimate uses of the sea, impairment of quality for use of seawater, and reduction of amenities. So it's noteworthy that the definition restricts the pollution to introduction by man, so that the harmful aspects which may be introduced by natural causes, they are not considered as pollution. However, you can also note from the definition that it extends beyond introduction of substances to include energy. So an example of the introduction of energy would be in warming of seawater, where, for example, if you've got water cooling in nuclear reactors, they might use the seawater as a coolant, which is then discharged back into the sea, and it is somewhat warmer than it was previously. Now, as I mentioned earlier, shipping is a small contributor to marine pollution. Most of the marine pollution arises from shore-based sources, and here there is a list on the left hand side. If you see the dot points, these dot points list the major types of marine pollutants. Some of these types are applicable to shipping as well, but I suppose when we are talking about marine pollution, let's quickly have a look at what are the sources of this pollution. So the first bullet point talks about nutrients, and these nutrients result from sewage, forestry, and farming activities. And what they do is they feed algal blooms in coastal waters. And when these algal blooms or algae, they decompose, they deplete water of oxygen. They can also spur the creation of algal blooms which have toxins in them, which can kill fish. For example, they are often known as red tides. Then you've got the sediments. That's the second dot point, sediments. And these are sediments which result from erosion of soil from mining, forestry, farming, and other land use. And what they do is they cloud the water and they impede the photosynthesis below surface waters. And they can also clog the gills of fish, and they can bury and smother coastal ecosystems. Then you have pathogens, which are pathogens means these are agents that carry disease or cause disease, and these result from sewage and livestock, and they can contaminate coastal swimming areas, seafood, spread diseases like cholera, typhoid, etc. Then you've got alien species, and ships are responsible for those. They are transported in ballast water, and what they do is they outcompete native species, and they can also introduce new marine diseases. Then we have got persistent toxins that result from PCBs. PCBs are polychlorinated biphenyls, basically human-made chemicals, such as used for electrical equipment. They can result from heavy metals. Heavy metals, for example, lead and mercury, which are which have a high molecular weight. And what they do is they poison and cause disease in marine life as well, and they can contaminate seafood as well. Then you've got oil, and low level of oil contamination can kill larvae and cause disease, but oil slicks, they kill marine life. They um, litter beaches and coastal habitat, and I think we have seen lots of pictures on the media about those. Then you have plastics. um, they can result from fishing nets, beach litter, and essentially, in a lot of places people throw plastics in gutters and in canals and rivers, and they ultimately flow out into the sea. And plastic entangles marine life. Plastics can also turn into what we call, or very small particles, and they can be eaten as well by marine life. Then you've got thermal um, sources of marine pollution, and I already mentioned, when seawater is used as a coolant, the discharged water from, say, a nuclear power plant is warmer than the original temperature. Noise pollution from bigger ships and machinery, that can be transmitted for, they say, thousands of miles underwater, and that can interrupt marine life. Finally, we have the air emissions. And with air emissions, the increasing carbon dioxide in atmosphere is believed to be absorbed by the ocean. And once it is dissolved in ocean, it produces carbonic acid, and that's something that corrodes the shells of marine organisms. Um, then there are ozone depleting substances like CFCs, chlorofluorocarbons, and these deplete the ozone layer. And what that does is it allows ultraviolet radiation to reach the surface, and that can kill plankton, which are at the bottom of the food chain. So they affect everyone. But if you can see from this image, um, you can see that maritime transport is, just it has a small contribution to the overall marine pollution. But because we are talking about, global scale, even that small proportion is very large in terms of the actual amount of pollution created. Um, there was a study done by United Nations in 1990, and that basically found that the maritime transport is probably responsible for about 12% of the total marine pollution. So most of these, pollution, 78%, or 100 minus 12 would be how much? 88% would be generated from land sources. However, I should caution you that these estimates were produced in 1990, and some people actually say that because land-based pollution has grown at a very rapid pace, maybe in percentage terms, the pollution from shipping is probably less as a proportion, but that doesn't mean that the amount of pollution is not significant. So, what's the basically impact of shipping? And this slide summarizes that. One is that shipping can or ships can release oils and chemicals, and this could be either due to accidental discharge of oil and chemicals, or it could be part of operation operational discharge. And then ships, particularly bulk carriers, they transfer invasive alien species, um, because they bring water to one place from somewhere else as part of the ballast. Ships use toxic chemicals, and toxic chemicals are used in the underwater part of the ship, and that's to prevent anti-fouling or to prevent fouling. And we did discuss that in one of the previous modules. There is also dumping of garbage and sewage from ships, and if you look at, say, passenger ships, you can imagine the amount of sewage that would be created. Ships have engines, so the engine exhausts, they 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 contain sulfur oxides, nitrous oxides, and carbon dioxide. And ships cause physical damage as well. They drop anchors, and there are trawlers who trawl the bottom of the seabed with nets. Um, Ships hit reefs, and they, of course, cause noise and wave disturbances as well. Now, if you look at this slide, now this is taken from the International Tanker Owners Pollution Federation, or ITOPF, and basically it shows you the quantities of oil spilt. Um, and this slide shows over the quantities of oil spilt over 700 tons. And ITOPF maintains a database of oil spills from tankers, and they have a database starting from 1970s. So what you would find is that the incidence of large spills is relatively low, and sometimes detailed information is not available. So I think what we should look at here is the trends. And what is quite apparent here is that the number of large spills has decreased significantly during the last 45 years or so, and such that if you look at the last decade, the number of major oil spills is less than three. The average number per year is less than three. Uh, if you think back to the growth of seaborne oil trade, except for a little bit of fall in the early 1980s due to the worldwide economic recession at that time, there has been an increase in seaborne oil trade, a steady increase. And as you would think that increased movements would normally imply that there is an increased risk of oil spills, the data here shows that there is a downward trend. So that is certainly something very encouraging. Now, if we turn our attention to the causes of oil spills, most incidents are caused due to something happens during what we might call operational operations. So that could be ships taking bunkers, or during loading or discharging in in ports, or it could be caused by accidents, like groundings, fire, etc. Most spills from tankers result from routine operations such as loading, discharging, and bunkering, and these would normally occur at ports or at oil terminals. The majority of these operational spills are small, and according to ITOPF, 90% of the oil spills involve quantities of less than 7 tons. Accidental causes such as collisions, groundings, hull failures, fires, and explosions, they give rise to much larger spills, and many of these incidents would involve quantities much in excess of, say, 700 tons. Now, you I think one thing to realize here is that when we look at the frequency and quantities of oil spilled, a very few large spills are responsible for a high percentage of the quantity of oil spilled. So, for example, in the 1990s, uh, nearly three quarters of the amount spilled was caused by just 10 accidents or incidents. In the 2000s, about half of the spilled amount was just caused by four incidents. So, figures for a particular year may be severely distorted by a single large incident. There have been some notable incidents which, from a ship operations perspective, I suppose they are important because they resulted in some conventions that we are meant to comply with. So, I suppose the first significant tanker incident was the accident involving the Torrey Canyon in 1967, and you can see an image of that on the left hand side of the slide. And this tanker in 1967 ran aground off the coast of England, and about 100,000 tons of oil was spilled into the sea. And the oil contaminated the coasts of both England and France. So, because of that, many governments thought that there is a need to establish an international regulation and compensation scheme because the cleanup costs can be quite large, and to compensate those who have suffered loss and damage caused by the spilled cargo. So in that time, or at that time, the IMO was known as IMCO, or the International Maritime Consultative Organization, and they organized a convention called the CLC Convention, or the International Convention on Civil Liability for Oil Pollution Damage. And under that convention, a compulsory insurance scheme was um, was prescribed so that those people who were affected by oil spills from tankers, they could be compensated. So that was the CLC convention, and we'll look at it in another slide. However, it was also argued that the carriage of bulk oil was not a problem for the shipping industry and its insurance. What about the companies who were transporting these oil or who owned this oil? And as a result of that, IMO came up with a so-called fund convention in 1971. And basically, its provision was that it had created a fund, not an insurance cover, but a fund which would cover the cleanup costs and loss and damage, which for some reason was not covered by the CLC convention. There was another issue that was raised by the Torrey Canyon disaster, and that was that the accident happened beyond the territorial sea of United Kingdom. And strictly speaking, at that time, as maritime law existed, United Kingdom didn't have any jurisdiction to do anything to the ship. I mean, ultimately, it did bomb the wreck to burn the remainder of the oil. But as a result of this incident, another convention called the Intervention Convention um, came about, which basically gave the right to a coastal state that is suffering or is likely to suffer marine pollution to intervene in that ship and do what's necessary. The next development was the Marpol Convention, by which or with which you are now perhaps quite familiar, certainly familiar with. And that was one of the first of the many major conventions that was organized under the then IMCO. The second incident was the Amoco Cadiz in 1978, and you can see a picture of that on the right hand side of the slide. And that was a tanker which spilled about 230,000 tons of oil, and Its steering failed in rough weather, and it finally broke up and sank when salvage efforts failed. And prior to the Amoco Cadiz, there were many countries around the world who, thought that, okay, yeah, maybe, you know, these are incidents that only affect, you know, small areas of the world, and they were not very supportive of conventions like Marpol. And but as a result of accidents such as the Amoco Cadiz, countries like France, they became a very strong supporter of Marpol. Now, during the 1970s and 80s, they say that the United States was not a very enthusiastic supporter of the international regimes for regulation until such time as an accident happened in Alaska in United States involving a ship called the Exxon Valdez. And this accident happened in 1989, and the Exxon Valdez spilled about 40,000 tons of oil into a very pristine area of Alaska. One um, one of the results of this marine pollution was that the USA created its own Oil Pollution Act. So, in one sense, it decided not to back the IMO but created its own plan. However, there was another accident that took place which involved a ship called Erica in 1999, and the oil spill from Erica basically um, created much more support for IMO conventions like Marpol. And, there was a lot of pressure on the European Union with accidents like the ones involving Erica in 1999 and the Prestige in 2002. There was a lot of pressure on the European Union to do something about it, but what it decided to do was not to go unilaterally, but to support the IMO conventions in order to control marine pollution. And so that sort of gives you a bit of a background as to where these various rules come from. And I mentioned the CLC and the Fund Convention in the previous slide. And so I think it's useful to talk about who pays for oil spills from ships. And basically, the International Convention on Civil Liability for Oil Pollution Damage, CLC convention, the first one on the slide, that's based on the principle of strict liability, means that owners of tankers that spill oil are liable regardless of whether they are actually at fault or not, and with very minor, a few exceptions. And under the CLC convention, a tanker owner has to maintain insurance or similar financial security to cover their liability against pollution damage. And they also have to carry on board each tanker a certificate showing that they do have the insurance cover. For most ships, that insurance cover would be provided by the protection and indemnity clubs or P&I clubs. The other significant convention that forms part of the compensation regime is the International Convention on the Establishment of an International Fund for Oil Pollution Damage, simply known as the Fund Convention. Um, this was amended by a protocol of 2003, and basically this establishes a fund called the IOPC fund, from which additional compensation is available where the limit of compensation available under the Civil Liability Convention is exceeded. Because under the CLC Convention, the maximum liability of a tanker owner is roughly about Australian 170, $180 million. But what happens when the damage is more? So in that case, the money for say cleanup costs or to um, compensate for those people who are directly affected by the oil spill, for example, costs associated with the fishing and tourism industries, they can be paid from money from this fund. This is financed by contributions that are levied on private companies or other entities that receive by sea an annual quantity of more than 150,000 tons of crude or heavy oil. Then there is also the so-called bunker convention, which is the third one on the list here. And essentially, this bunker convention, the International Convention on Civil Liability for Bunker Oil pollution damage, that was designed so that ships that were not tankers, such as container ships and bulk carriers, but they carried a lot of oil too, as fuel oil, and they needed to be some way of making sure that, in case the bunker fuel spilled, then some liability could be placed on the shipping companies. And essentially what this convention does is it makes the ship owners strictly liable for fuel oil spills, and they have to carry compulsory insurance to cover any pollution damage from these. The fourth one on the slide is the so-called HNS convention, and I won't read the full title because it's quite big. You can read it yourself, but I've highlighted on the slide in yellow the HNS convention. And the HNS convention is somehow similar to the CLCN Fund Convention, but it goes further in that it covers not only pollution damage, but also the risks of fire and explosion, including loss of life or personal injury, as well as loss or damage to property. And the HNS, they are defined by reference to list of substances that are included in various IMO conventions. So these could be oils, noxious liquid substances, liquefied gases, harmful and hazardous materials such as those you might have come across, or that you came across under the IMDG code, and solid bulk materials defined as possessing chemical hazards. And the convention also introduces strict liability and a system of compulsory insurance and insurance certificate for the ship owner. The convention is the HNS convention, that is not yet in force. So if we look overall at the IMO regulatory control to prevent pollution and to control pollution, this slide basically shows you the five major areas where the IMO efforts have been targeted. So looking at the top of the slide, you've got the ship emissions. So there are some IMO requirements concerning the emissions from ships' engines. There are requirements concerning greenhouse gases, basically carbon dioxide. Then there are requirements for ship discharges concerning oils, chemicals, garbage, and sewage. There are requirements for the treatment of ballast water or ballast water management so that alien species do not travel from one part of the world to another. Um, there are requirements concerning the ship coatings that are used. We covered that in one of the previous modules. And there is also, in recent years, more work done in IMO on improving ship efficiency. And the idea being an efficient ship would use less fuel, so then there would be less carbon dioxide and other emissions. MARPOL, if you look at MARPOL, it's a quite a technical document, and it's got 6 annexures, and each of these annexures covers the requirements about when, where, and how a pollutant can or cannot be put into the sea or into the environment. And it also talks about the equipment that the ship should have, the way ships have to be constructed, and the certificates that they have to carry. Annexure 1 covers oil, Annexure 2 covers noxious liquid substances, basically chemicals. Annexure 3 covers the pollution by harmful substances that are carried by sea in packages. Uh, Annexure 4 concerns sewerage. 5 deals with garbage, and Annexure 6 deals with air pollution. Very, very quickly, just to give you an example of the type of requirements stated under MARPOL. So if you look at MARPOL Annexure 1, that talks about discharge of oil. And if we talk about discharge of oil, first of all, the ship has to be outside special areas. And the special areas are the enclosed seas of the world, like the Mediterranean Sea, Red Sea, etc. Very fragile ecosystems such as the Great Barrier Reef and the Torres Strait, they are protected by a separate mechanism, which is whereby these areas are declared particularly sensitive sea areas. So, like the Great Barrier Reef is considered a particularly sensitive sea areas. And essentially, what that means is that the authorities in this case, in PSSAs, they can impose greater restrictions on what happens than if it was just considered a special area under MARPOL. And on the right hand slide, or side of the slide, you can see some of the requirements for discharge of oil from non-cargo spaces. That means from engine rooms. So it talks about things like, ships should be proceeding en route. There should be oil filtering equipment um, on board. There have to be an oil record book, and the content of the oil has to be a very small quantity in any mixture of oily water. So you can see from the slide, it's meant to be as low as or maximum 15 parts per million. MARPOL also requires a shipboard oil pollution emergency plan, or SOPEP, to be established. And basically, the SOPEP would include a procedure that would be followed by the ship's crew to report an oil pollution incident, a list of persons or authorities to contact, a detailed action plan to be taken up by the ship's crew to reduce and control the discharge of oil, and designated procedures and point of contact for coordinating shipboard action with both local as well as national authorities in combating the pollution. I mentioned earlier that most of the oil spills, they take place during that they are small in quantity, but they take place during routine operations such as bunkering. And if you think about bunkering, you can take very small, very simple precautions. So precautions such as making sure that if there is any oil spillage on the deck, it doesn't flow back into the sea. So you block the scuppers, making sure that tank vents have got drip trays or save walls, so that if the oil overflows, it would be collected by those trays rather than flowing everywhere. Making sure that the oil response equipment is on standby, so that could be special chemicals. On very, very small boats or small fishing boats, it could be kitty litter, that can be used to mop up oil as well. Bunkering operations should always be supervised, so there should always be a crew member present at the manifold where the oil is coming in. Somebody should be monitoring the quantity and rate just to make sure that the oil is actually going where it is meant to go, and making sure that the ship's movement is not excessive. That is assuming that the ship is tied to a jetty, making sure that the ship doesn't move too much, otherwise the connection at the manifold between the, say, the bunker barge or the ship, that can be broken. Let's turn our attention to garbage disposal. And this slide looks like it's very wordy, but it's actually very simple. The garbage disposal requirements under MARPOL. This slide summarizes the requirements for ships when they're outside special areas. Um, Australia is outside special areas, so let's look at that. And essentially, what you can see is that there are requirements, first of all, depending upon the type of garbage, and secondly, how far the ship is from the nearest land. So, if we are talking about food waste, if it has been ground down to very small pieces, then the discharge is permitted at least at a distance greater than 3 miles, nautical mile, from the nearest land. If it has not been ground out, then the ship has to be at least 12 miles from the nearest land. Now, you do have cargo residues that have to be disposed of. On bulk carriers, the holds have to be washed down, and often the washings themselves will have, mm, you know, uh, the residues from cargo. And these discharges, are permitted. So if it is just the cargo residue, then the discharge is permitted. Ship has to be more than 12 miles from the land. Um, Similarly with cleaning agents and additive as well. here, of course, we have to make an assumption that these cargo residues and cleaning agents, these are not harmful to the marine environment. In other words, they are not classified as marine pollutant. All other garbage, plastics, cooking oil, floating dunnage, paper rags, glass, metal bottles, etc., they are now prohibited. Until just a few years ago, some of these could be discharged or disposed of at sea, no longer. So we now have stricter requirements, and essentially those requirements are, first of all, that the remaining garbage should be disposed of to a shore reception facility. So you keep it on board and dispose it off ashore. You have to display special or suitable placards where passengers and crew are likely to throw the garbage out from. So here on the right hand side of the slide, you've got an example of the type of placard that could be displayed. Ships are required to have garbage management plans. Basically, those plans contain procedures for minimizing, collecting, storing, and processing and disposal of garbage. And they also have to maintain a garbage record book to record every garbage that is disposed ashore or at sea. As far as sewage is concerned, by sewage, we're talking about the stuff that comes out from toilets, other drains, shower rooms, medical rooms, and on cattle carriers or animal carriers, from animal pens. If a ship has an IMO approved treatment plant, then the discharge of sewage is permitted, but you should always, or the ship should always check local laws. So if the ship is in port, the ports might, or the port authority might not allow any discharge of sewage, even though the ship might be having an IMO approved treatment plant. Secondly, if the ship has got a commuting or and disinfecting system, not a fully IMO compliant treatment plant, then it can discharge the sewage at a distance greater than 3 miles from land. Otherwise, it must have a holding tank, and then it can discharge the untreated sewage from more than 12 nautical mile, or it keeps the sewage inside the holding tank and discharges it to a shore facility when the ship is in port. Talking about or turning our attention to air pollution, then, although the air pollution from ships does not have the dramatic impact as, for example, say an oil spill, it does contribute to the overall air quality and also affects the natural environment, such as through acid rain. And so, what MARPOL does is it limits the main air pollutants that are contained in the ship's exhaust gases, and these include sulfur oxides, nitrous oxides, and it also prohibits deliberate emission of ozone depleting substances such as halons and CFCs. In recent years, the main changes are a progressive reduction in the emissions of sulfur oxide, nitrous oxides, and particulate matter, and the introduction of the so-called emission control areas, where the emission of nitrous oxides as well as the sulfur oxides and particulate matter is further restricted. So that means that ships have to have special equipment. It has affected the design of ships' engines. It has affected the quality of fuel that the ships can burn. And it has also meant that incineration of some products on ships, incineration means the burning of some products on ships, has been prohibited. So if we look at the requirements for fuel, now on this slide, what you can see is that the limit of the sulfur content on the fuel is being progressively reduced. You've got two lines there. One is the black line and one is the orange line. The orange line shows you the fuel caps, sulfur fuel caps, or caps on sulfur content in fuel when the ship is in the so-called sulfur emission control areas or SECAs. Basically, the Baltic and North Sea, English Channel, and a few other areas, whereas the black line shows you the caps for all other ships when they are not in the SECAs. And the percentages are percentage by weight. So what you can see is currently, if the ship is in a SECA, the sulfur content cannot exceed 0.1%. Whereas if the ship is in some other areas, the sulfur content of the fuel should not exceed 3.5% by weight. But very soon, we are talking about 1920 onwards, all ships who are outside SECAs, they would need to burn fuel whose sulfur content does not exceed 0.5%. Now, of course, the sulfur emissions can be reduced by decreasing the sulfur content of the fuel used, but you can also physically remove sulfur from the exhaust gases, or ships can change fuel. For example, use natural gas as fuel rather than sulfur. There was a study done by IMO, which was called the IMO Greenhouse Gas Study in 2009. And what it basically found was that about 2.7% of the global emissions of carbon dioxide was due to international shipping. So, that's although it's 2.7%, IMO estimated that it was about 870 million tons of carbon dioxide that was being that international shipping was responsible for. And since carbon dioxide is the most important greenhouse gas emitted by ship, both in terms of quantity and its potential for other things, such as its contribution to perhaps warming of the globe. Um, there, the study did identify significant potential for reduction of greenhouse gas emissions through both technical and operational matters or measures, I should say. So, measures to reduce the greenhouse gas emissions from international shipping are aimed at improving the energy efficiency for new ships through improved design and propulsion technologies. And for all ships which are existing or new, primarily through improvement in operational practices. So, one measure that IMO has implemented is the so-called development of the so-called Energy Efficiency Design Index, or EEDI, for new ships. And the EEDI is mandatory for new ships, and for ships um, including new ships and existing ships, a ship energy efficiency management plan is mandatory. So the EEDI, or the index, that doesn't prescribe how energy efficiency has to be achieved. It's based on a performance based mechanism, which basically leaves the choice of technology to the industry. So as long as the required energy efficiency level is attained, ship designers and builders, they are free to use the most cost effective solution so that the ship can achieve the um, design energy efficiency that IMO prescribes. As far as the efficiency management plan is concerned, that basically establishes a mechanism for companies to improve the energy efficiency of ship through measures such as improved maintenance of the hull and propulsion systems so that ships don't burn too much fuel, better or more efficient voyage planning, better weather routing so that ships, you know, um, burn less fuel or arrive at their place quickly, um, making sure that the speed is optimized for less fuel consumption, etc. So each ship is required to keep a ship-specific management plan, which can also form part of the um, ship safety management system that we'll talk about in the next module. Now, the EEDI standards, they will be phased in progressively till the year 2025. So currently, they are not applicable to all ships. Now, obviously, if we reduce fuel consumption, we can reduce emissions. And this figure on the left hand side, if you read that, it presents transport efficiency in terms of fuel consumption per ton mile of cargo moved for container ships as a function of capacity in TEUs. And as you can see from um, reading the left hand side of the slide, uh, significant reductions in fuel consumption per TEU transported can be realized through economies of scale of employing larger capacity vessels. So, in other words, the bigger the ship, the less fuel per TEU is burnt. Having said that, I think we need to be cautious here. These efficiencies are only achieved if the ship is full. So, if you've got a very large ship which has got a lot of TEU capacity, but if it's carrying only a small amount of cargo, then that efficiency is not realized because it's operating a bigger engine. On the right hand side, you can see the impact of reduction in service speed. And essentially, as the slide shows, that reducing speed by 1 knot for a ship of around 4,500 TEU and above can reduce the propulsion fuel consumption by 12 to 15%. And for oil tankers, reducing speed by 1 knot can reduce the fuel consumption by 17 to 22%. So you can see that even existing ships, even though they are not meant to comply with the energy efficiency index, through operational means, they can reduce the fuel consumption and hence the air emissions, the harmful air emissions. Lastly, we can turn our attention to marine invasive species. And what do we mean by marine invasive species? Well, marine ecosystems are populated by different species. There are animals, plants, micro organisms, and they have evolved over a period of time in isolation, separated by natural barriers. But with shipping, those barriers have been broken. So the ships do bring, say, through the ballast water species from one part of the world into another. When that happens, the new species that come into an area which in the past had been geographically isolated, these are called introduced species or alien species. Now, many of these new species, they will die in their new environment because they have not evolved to cope with the new situation. But some of them thrive and they start to take over native biodiversity, and these are known as invasive species. When an invasive species establishes itself in a new environment, it is not subject to the natural controls that kept its population number in balance from where it came from. So it may not have any natural predators, and so they tend to increase rapidly in size. And one example of that is the Japanese starfish, and you can see the picture of a Japanese starfish on the left hand side. Looks very pretty. It's large yellow and purple, and the species is native to Japan, northern China, Korea, Russia, and the far North Pacific. And it's thought that this species was introduced in Tasmania, either as larvae through ballast water or as fouling on ships that used to come to Tasmania from Japan. Anyway, it's here in Tasmania. It's a voracious predator. It eats virtually anything it can find that is no longer than one of its own arms, so up to about 50 centimeters. It's very fond of shellfish, crabs, sea urchins, other starfish, fish eggs, and similar organisms. And it can detect and dig out prey that is buried in sand. And if any one of you have been to the Derwent estuary in Hobart, you can see um, plenty of these around. And there is no practical method known to eradicate the species after it has become established. So, to deal with um, control, or in order to control and hopefully prevent these marine invasive species from being transported from one part of the world to another through ships' ballast water, Uh, the Ballast Water Management Convention was or took place in 2004, and it's in force now very recently from the 8th of September 2017. So essentially, what the Ballast Water Management Convention requires is that every ship should have a ballast water management plan. It should have a ballast water record book and a ballast water management certificate. So the record book should record every time the ballast is handled on the ship. New ships should have a ballast water treatment plant, or they should treat the ballast water either through filtration, chemical disinfection, ultraviolet treatment, or any other treatment. Could be heat treatment, whatever is cost effective for the ship. Existing ships, they are exempt from the installing the ballast water treatment plant until the time they have the next renewal survey. But until such time, they should exchange ballast water at sea. What that means is that when they are in port and if they're taking ballast water, when they go out to sea, they should exchange the water that was from the coastal area with water from the deep sea. And the idea there being that many of the coastal species, they don't survive in deep sea water, and the deep sea water species, they don't survive in coastal waters. So when the ship comes to the next port and discharges the water which was taken in from the deep sea, it would contain organisms that hopefully wouldn't survive in the new coastal environment. So we have covered in today's presentation basically briefly looked at the impact of shipping on marine environment, and we've looked at the IMO requirements for prevention and control of pollution. Basically looked at the pollution control requirements for oil and chemicals, garbage and sewage, ship emissions, and ballast water management. We've also briefly discussed liability for pollution damage. So in the last three modules, we have focused quite heavily on the regulation of the shipping industry, and perhaps it's time to reflect on the reasons for the high level of intervention in ship operations. And is it because the stakeholders are concerned about the ability of the shipping industry to maintain high standards by itself? Are there any grounds to believe that quality in shipping operations can only be assured through strict regulations? Food for thought, but since I mentioned the word quality, I can point out that we will cover the issue of quality management in the next module. Bye for now.